Now we'll discuss Kubernetes object management. All Kubernetes objects are identified by a unique name and a unique identifier. Let's return once again to our example, in which we want 3 Nginx web servers running all the time. Well, the simplest way would be to declare 3 pod objects and specify their state. For each, a pod must be created and an Nginx container image must be used. Let's see how we declare this. You define the objects you want Kubernetes to create and maintain with manifest files. These are ordinary text files. You may write them in YAML or JSON format. YAML is more human readable and less tedious to edit, and we will use it throughout this specialization. This YAML file defines a desired state for a pod, its name, and a specific container image for it to run. Your manifest files have certain required fields. API version describes which Kubernetes API version is used to create the object. The Kubernetes protocol is versioned so as to help maintain backwards compatibility. Kind defines the object you want, in this case a pod, and metadata helps identify the object using name, unique ID, and an optional namespace. You can define several related objects in the same YAML file, and it is a best practice to do so. One file is often easier to manage than several. Another, even more important tip: you should save your YAML files in version-controlled repositories. This practice makes it easier to track and manage changes, and to back out those changes when necessary. It's also a big help when you need to recreate or restore a cluster. Many GCP customers use cloud source repositories for this purpose, because that service lets them control the permissions of those files in the same way as their other GCP resources. When you create a Kubernetes object, you name it with a string. Names must be unique. Only one object of a particular kind can have a particular name at the same time in a Kubernetes namespace. However, if an object is deleted, its name can be reused. Alphanumeric characters, hyphens, and periods are allowed in the names, with a maximum character length of 253. Each object generated throughout the life of a cluster has a unique ID generated by Kubernetes. This means that no 2 objects will have the same UID throughout the life of a cluster. Labels are key value pairs with which you tag your objects during or after their creation. Labels help you identify and organize objects and subsets of objects. For example, you could create a label called app and give as its value the application of which this object is a part. In this simple example, a deployment object is labeled with 3 different key values: its application, its environment, and which stack it forms a part of. Various contexts offer ways to select Kubernetes resources by their labels. In this specialization, you will spend plenty of time with the kubectl command. Here's an example of using it to show all the pods that contain a label called app with a value of Nginx. Label selectors are very expressive. You can ask for all the resources that have a certain value for a label, all those that don't have a certain value, or even all those that have a value in a set you supply. So, one way to bring 3 Nginx web servers into being would be to declare 3 pod objects, each with its own section of YAML. Kubernetes' default scheduling algorithm prefers to spread the workload evenly across the nodes available to it. So we'd get a situation like this one. Looks good, doesn't it? Maybe not. Suppose I want 200 more Nginx instances. Managing 200 more sections of YAML sounds very inconvenient. Here's another problem. Pods don't heal or repair themselves, and they're not meant to run forever. They're designed to be ephemeral and disposable. For these reasons, there are better ways to manage what you run in Kubernetes than specifying individual pods. You need a setup like this to maintain an application's high availability along with horizontal scaling. So, How do you tell Kubernetes to maintain the desired state of 3 Nginx containers? We can instead declare a controller object whose job is to manage the state of the pods. Some examples of these objects: deployments, stateful sets, daemon sets, and jobs. We'll meet all of these in our specialization. Deployments are a great choice for long-lived software components, like web servers, especially when we want to manage them as a group. In our example, when kubescheduler schedules pods for a deployment, it notifies the Kube API server. These changes are constantly monitored by controllers, especially by the deployment controller. The deployment controller will monitor and maintain 3 Nginx pods. If one of those pods fails, the deployment controller will recognize the difference between the current state and the desired state, and will try to fix it by launching a new pod. Instead of using multiple YAML manifests or files for each pod, you used a single deployment YAML to launch 3 replicas of the same container. A deployment ensures that a defined set of pods is running at any given time. Within its object spec, you specify how many replica pods you want, how pods should run, which containers should run within these pods, and which volumes should be mounted. Based on these templates, controllers maintain the pod's desired state within a cluster. Deployments can also do a lot more than this, which you will see later in the course. It's very probable that you'll be using a single cluster for multiple projects. At the same time, it's essential to maintain resource quotas based on projects or teams. By the way, when I say projects here, I mean projects in the informal sense of the word, things you and your colleagues are working on. Each Kubernetes cluster is associated with one GCP project in the formal sense of the word project, and that's how IAM policies apply to it and how you're billed for it. So, how do you keep everybody's work on your cluster tidy and organized? Kubernetes allows you to abstract a single physical cluster into multiple clusters known as namespaces. Namespaces provide scope for naming resources such as pods, deployments, and controllers. As you can see in this example, there are 3 namespaces in this cluster: test, stage, and prod. Remember that you cannot have duplicate object names in the same namespace. You can create 3 pods with the same name, Nginx in this case, but only if they don't share the same namespace. If you attempt to create another pod with the same name, Nginx pod, in namespace test, you won't be allowed. Object names need only be unique within a namespace, not across all namespaces. Namespaces also let you implement resource quotas across the cluster. These quotas define limits for resource consumption within a namespace. They're not the same as your GCP quotas, which we discussed in an earlier module. These quotas apply specifically to the Kubernetes cluster they're defined on. You're not required to use namespaces for your day-to-day management. You can also use labels. Still, namespaces are a valuable tool. Suppose you want to spin up a copy of a deployment as a quick test. Doing so in a new namespace makes it easy and free of name collisions. There are 3 initial namespaces in a cluster. The first is a default namespace for objects with no other namespace defined. Your workload resources will use this namespace by default. Then there is the kube system namespace for objects created by the Kubernetes system itself. We'll see more of the object kinds in this diagram elsewhere in this specialization. When you use the kubectl command, by default, items in the kube system namespace are excluded, but you can choose to view its contents explicitly. The third namespace is the kube public namespace for objects that are publicly readable to all users. Kube Public is a tool for disseminating information to everything running in a cluster. You're not required to use it, but it can come in handy, especially when everything running in a cluster is related to the same goal and needs information in common. You can apply a resource to a namespace when creating it using a command line namespace flag. Or you can specify a namespace in the YAML file for the resource. Whenever possible, apply namespaces at the command line level. This practice makes your YAML files more flexible. For example, someday you might want to create 2 completely independent instances of one of your deployments, each in its own namespace. This is difficult if you have chosen to embed namespace names in your YAML files.